So I'm going to talk to you about this study that I kind of was a little bit of a latecomer to, but that my colleagues at Hawkyard Research Institute were designing, and you looked at it as an opportunity to compare our open formula reference diet with other commercially available and in development diets. So first, to start out, a lot of you are very intimately familiar with marine fish larvae, but they're among the hardest vertebrates to culture in the world. They're among the smallest vertebrates, and they're not fully developed. So they don't have the full suite of digestive pathways, metabolic pathways, and digestive organs, and able to find food as we would see in later, more developed fish. And this is just kind of the classic, some figures I took from Kolkovsky, 2001, but just showing, as these early stage animals first hatch, they sometimes have just a very alimentary digestive tract. And then as they grow and develop, you see organogenesis happen, the development of lots of kind of key developmental things that influence their ability to find and utilize food. So a pretty standard feeding regime for marine fish larvae, and this is the one that's used for our study and by Hawkyard Research Institute for California yellowtail, Seriola, is that you start them on the smallest live feeds, these rotifers, and then transition them onto larger artemia, also a live swimming feed, and then eventually transition them onto dry food, which is really what we want. That's going to be the easiest. And there's a big period of overlap while they're receiving both these different organisms, but particularly the artemia and the commercial diet get a good deal of overlap, so they're kind of feed trained onto these commercial microdiets. So, this has a really big implication. So how we treat animals in their earliest stages of development can have long-term effects. So you might have, early nutrition leading to different growth trajectories over time. This early nutrition can affect things like the animal's overall robustness and response to stress and disease subsequently down the road. And also, their development is going to lead to whether or not they're developing normally or abnormally, which can have, fish health consequences. The good thing about commercially available microdiets, they're easily accessible for the most part. They're appropriate and consistent formulations, and they're kind of meeting that general niche. However, they have a lot of things that need to be considered and further developed. So the acceptability, the ability of these animals and desire of these animals to consume the diets is a really big one, getting them to eat it, and that's influenced by how the diets taste and how fast they sink. Formulating these diets to meet the needs of the animals is important. Those ingredients have to be digestible. And then finally, the nutrient retention. They have to retain their nutrients through this aqueous medium, which I won't talk much about today. But we're developing an open formula reference diet. This was actually originally a formulation that was developed by two of the guys in this room, Rick Barrows and Mike Rust, really kind of spearheaded a lot of this work. And we've taken this open formula concept and really moved forward with it and testing it with more species, and now trying to further develop this open formula reference. So it's open formula, so it's basically an open source recipe that people can use. And the advantage is that this makes it more transparent. We suggest this could be a reference diet, so if it works well, then we can now have something that we can use from one study to the next, across studies. We can share this with, I've already shared it with at least one commercial company, two, I suppose. It's open source, so anyone can use it for a wide variety of uses. We make our a micro-extruded marumerized diet in-house. So our open formula is we first produce a noodle, and then that noodle runs through a spherinizer to make these nice spherical beads. And then we run it through a fluidized bed dryer just to get it down to under 10% moisture. Now, what we did was we took our open formula and we compared it against the 4 other commercial diets. So 3 of these are commercially available: the Alltech Advance, the Algonor's Wean, it's a trophy product actually, and then the Otahime. Those are all off-the-shelf commercial products. And then Ziegler sent us a diet that they're developing in-house. So that's the 4th one there. And then our open formula reference diet was made at MEM. I'm going to call it the MEM Humane Diet for convenience. And I just want to point out on this slide that you can see nothing is similar about these. They're not formulated to be balanced in any sort of way. We're just throwing all these different diets to see what works the best. This was done under a pretty standard growth protocol that Hawkyard Research Institute uses. And this really focused on this period where they're on artemia at the beginning of this weaning period, and then towards the second part of the study, they're completely on the commercial microdiet, so it's during the period of weaning. And then we measured a lot of stuff. So here's the growth results. Just jump straight to the growth part of this. What we see was that this Algonor's wean diet actually resulted in the highest growth of the larvae. This connecting letter report, these are overall effects from a repeated measures model. So you can see that I think importantly that I want to point out that one, and then also our MEM diet, this open formula reference diet, did as well as almost all the commercial diets, including Otahime, which was really that was our goal at the beginning. If we could just do as well as Otahime, we thought we'd been done well. But you can see there's variability. The standard length has quite a bit of difference among the overall growth effects. So this is where I thought there was a really fun opportunity in this study. Sorry, there's the Algonor's, and then there's the open formula. I forgot about my animations there. But the cool thing is these were made all over the world. We had 2 diets made in North America, 1 made in the Netherlands, 1 made in Norway, and 1 made in Asia. And that means they're using ingredients from all over the world, because we use regionally available ingredients for making these diets. And they're made with different formulations and through different processes. So there's a ton of different things. And so I just put it in a big model, right? And the screen, basically running like 150 regressions. And each regression is regressing the growth metric, in this case dry weight, against nutrient concentrations in the diets. And this is really fun. Now this is only showing correlation. It's not saying causation, right? We're just saying that these attributes of the diet are correlated with growth. And the second thing is we could put things like sink rate in there and have different, because there's different sizes of diets as categorized by different life stage sink rates. So we can just put a whole bunch of parameters in here. And the ones in the blue, the p-values in the blue have been corrected for the multiple comparisons problem for the statisticians in the room who are worried about that. So those are the most highly correlated and significantly correlated. And then this is standard length, and then the nutrients and factors in bold were flagged for both dry weight and length. And what stands out to me here, and where I just don't have enough time to talk about this, is that a lot of these things that are flagged are not what we think about typically when we're formulating the diets. So glycine is flagged pretty high up on the list. This monounsaturated fatty acid, 21 omega 11, shows up for both length and dry weight. And this is not something we typically have a lot of conversations about in terms of fatty acids. So what I'm proposing, what I think this approach is really useful, is just kind of thinking out of the box. Like, one, what sort of things might we be missing in marine fish larvae? And you have to appreciate, marine fish larvae are some of the fastest growing animals on Earth. Their daily growth change is just insanely higher than anything else we see in fish aquaculture. And so they have this huge metabolic demand. And at the same time, they're not fully developed. So you've got these rate-limited species, because they don't have the full suite of enzymes yet, and then asking them to go in overdrive to grow as fast as possible. And what I'm saying is maybe what we're doing is we're outpacing these, our essential amino acids. In a traditional model, animals can take essentials and turn them into non-essential nutrients. But in what I'm suggesting, and what I'm not the first one to kind of have these ideas about fish larvae, obviously, but is that we may be needing to think more comprehensively about some of these what we'd consider non-traditional or non-essential nutrients, and providing those directly, and it may be just a subset of them. But anyways, it's kind of changing how I'm thinking a little bit about how we can move forward with some of this research and find some things that actually might be really important that we've been missing. So in summary, our open formula did really well. We're really excited about that. If you want a kilogram, I'll send you a kilogram for free to try with a new species. So that was Rick's idea. Steal that. But we really want to test this thing out and get it used as a reference diet, and we can build bigger projects on that. Algonor's did really well, so there's something to be learned from that particular product. But all of our commercial diets did quite well. And then finally, this concept of that there might be some things we traditionally think of as non-essential that actually for a marine fish larvae in those early stages may be more needed than we formally appreciate. So with that, I just want to thank the Hub Sea World Conservation Fund for funding this. Our National Sea Grant project has covered a lot of the nutrient analyses that we were able to do value add to this project. And then all our commercial companies have been great partners and sending us diets for free and just willing to have good, nice dialogues about this. So really appreciated that. And with that, thank you very much, and I'll take any questions. So condition factor, I don't, let me come back here. Yeah, yeah. First of all, I don't even know why I put that up there anymore, because condition factor is a real weird thing. In fact, you'll see condition factor go down in best performing diets. And it's because what I think is happening is you end up with these fish that are kind of, they get pushed further along in development. And what's happening is there's what's the word I'm looking for, but it's not a one-to-one direct relationship. There's indirect relationship between length and growth, and that is developmentally pushed and nutritionally pushed. And so what you end up with these longer larvae that look like they have poor condition, but they're actually just in that kind of pushed in that next phase of development. That's my hypothesis, but it doesn't seem to be a very good indicator of like best performance in these early life stages because of this, asymmetrical kind of relationship between those things. Yeah, so I think these, geez, what are they? Dry weight, they're like 0.5 gram. Yeah, at the end of the trial. Yep. Yeah, good question though. That's, yeah.
Some of these correlated nutrients to amino acids.
Yeah.
So do you think that they were affecting the palatability of the?
Yeah, so that's the thing is we don't really, and first of all, a lot of things could be autocorrelated, right? It might be that there's 1 or 2 factors that are driving it and the rest just kind of get pulled along with it. The other thing is, yeah, so glycine, that's a great one to point out. We know that's a very strong feeding attractant. And that also sink rate gets flagged, at least in the less significant, in this non-corrected fraction. So, both of those things related to feed uptake more than anything. And yeah, certainly, like, I don't think this is a, oh yeah, also, well, threonine is essential, but, half of the amino acids that are flagged on our list are non-essential amino acids as well. So yeah, again, I don't want to do too much arm waving. It's just more of a conceptual framework to move forward with, and also the value in running studies like this. This was powerful because it was made with 5 really different diets from across the world. If we did the same thing with 10 diets, the power in a regression is having a lot of change and a lot of places on that line. So it's really, you couldn't do this with like ANOVA, and like even a lot of more complex models are just harder to interpret. And so, yeah, good point, Chris. Thank you. Yeah, I think glycine, like, there's a lot of things going on here. That's the point.
Hey, one more question.
I'm glad I finished pretty fast, because this is my favorite part, is like seeing what you all think about this.
Para mí, porque por eso hay más.
Yep.